This board is going to be a replacement board. Let me know when you're ready to go.
Hmm?
You ready to go?
Oh, yeah.
Oh, okay. So this board is going to be a replacement board, and we can look in the mill later. But
Okay.
this daughter card is it takes the signals from the servo plus or minus 10 volt, and it outputs plus or minus 10 volts, and it takes the linear encoder pulses and conditions those in a way to be fed into the PCI card that goes in the PC.
And that's the Mesa.
So this is the Mesa card,
Okay.
and these are also from that same company. This is just optically isolated I/O.
Okay.
So 50-pin ribbon cards go from each one of these,
All right.
and this is that Xilinx micro FPGA programmable. So basically, you can tell this thing to be whatever kind of I/O you want. That's called anything I/O card. And so then the software will run this. And these can be configured as I/O pins to sense like the mill's stop, e-stop, or something like that, and then to output to run the motors. So the software will drive. The software has drivers for this PCI card, and that's in the integrator's manual of what you need to do to get it working. And then
Oh yeah, on
actually
the
plug right in.
this one here, right?
The integrator's
Okay,
manual.
okay.
Yep, exactly. So like this, I can show you over here.
Oh, Chris is giving a tour, yeah.
So this is the mill we're going to convert, actually. And,
The H.H. Roberts.
yeah, that's actually just the head.
Oh, okay, okay.
That's just I think that's just the spindle manufacturer.
Oh. What is this? It's all kinds of different names on here.
Yeah, so
The Champ and the Web.
Yeah, I'm not. It's
Well, whatever.
It's like a generic.
The heaviest of the heavyweights.
Yeah.
All right. All right. Okay. Yeah. Let's get to the.
So there's a PC over here that's the old school PC.
Okay. Oh yeah. All right.
By our project if we do it right.
Mm-hmm.
And then this is the. So these are the servo motors right here.
Right.
And coming through here, in is the power and signal to tell it whether to go forward, backward, and how fast. And
Okay.
out goes the encoding to say how much it's moved. And then. Basically,
I'm behind you.
how much light we have there. So this is the board we're gonna replace.
Okay.
You know, these are
This is probably my most recent favorite.
those headers will pull off and go right to these headers.
Yep.
All right.
Versus got all the
And then those three down there are servo
coolest I've seen in a while. We've got
amplifiers, so they're power amplifiers, one for each axis. Is the XYZ. There's some, power supply and some relay type stuff to run the spindle, and some other relays down there. But basic idea is this will be we'll take that card out, put this card in, put all the headers back in the same place, but then run it off of a PC it's actually this PC that we got that's
Okay.
destined hopefully ultimately to be the EMC2 PC.
And so since you're saying that yeah, you can just still keep that. So if you want to plug that back in, you still
Yeah.
have all the stock, whatever.
Yeah, exactly. So either during development or whatever the case may be, we can keep that card basically in place. Because the problem is, if that card would break, it's like it would be like $800 or $1,000. It's a very proprietary commercial system. Now it's a very old system, so there's it's really hard to get replacement parts for that. So this move, I'm going to put all the schematics for this out as open, and the idea would be these are not open source hardware.
Okay.
But the board and everything like that, we can document the heck out of it, and it's relatively lower price, more commodity type hardware than the commercial stuff that's in here. So it'll help move us in a direction of if something breaks, we can get it back working much more economically. Where we're at currently.
I was going to say, I don't know a gosh darn thing about milling, but I've been working on confectionery a lot lately. If you're, I could help you with chocolate tempering and/or cake decorating.
Very good. I may have some frosting questions for you when we get into
Oh,
it.
I've been moving into. I've been learning how to do fondant. I might just.
Oh, okay.
Sorry, not.